Yeah, let's get started. So, as we probably all understand, this is the HPC world as we've got it today. We've got our users logging in via login nodes into a giant pool of computers with a high-speed network, InfiniBand or some other form of RDMA network, and a giant big batch of high-performance storage. Sort of seems like an odd space to start, but we need to know where we are so that we can know where we're going. Yeah, good job. Jobs are generally one application, which is a very big difference that we'll see in a few minutes between AI workloads. Users generally use files from a high-performance storage. There's not as much external or continuous external usage of data. Jobs are generally a standalone job. You fire off a job script which you've put together that pulls in together a certain number of nodes and resources, and then it runs the processing job and it spits out work. I mean, we all know the batch schedules, we've all been using them for a very long time. The other big difference is, of course, modules or library availability. Generally, most machines will have a pre-configured suite of libraries and modules that your users are expecting to use and will then use with their workloads that they're running. In the land of ML and AI, things are a little bit different because of where those things have been going for a long time. A lot of the workloads are multi-component, multi-stage workloads. For example, a RAG has multiple stages and multiple models. You've got like your initial model which does the classification, you'll have a reweighting model, you potentially have reclassifiers and other models as part of that workload as the data goes into and then is used and maintained inside your RAG. Excuse me. A lot of AI workloads have obviously got heavy use of containers, Docker, and the like. Interactivity is often required with AI models, not as much as there might be with a lot of traditional HPC workloads. For example, just the obvious answer of an LLM, you might want to interact with the LLM while it's running in inference mode, whereas you don't generally interact with your computational chemistry workload while it's actually doing the processing. And obviously with the way things are going today, the rapid pace of AI means that the requirements and size and dimensions and shapes of these workloads change quite frequently and almost violently from time to time, depending on what the latest breakthroughs is from the various different groups that are producing AI or even internal development. This means it's more suited to on-demand models, which is why you see a lot of AI workloads run on clouds and that sort of platform, because as the model grows or the number of models grow for the particular workload, it can be scaled up easily without having to resubmit everything from scratch. You can just add an extra VM, add an extra container, plug it all together, and it just keeps on going. Whereas with a more traditional batch, obviously you'd have to wait for the one batch to run, rewrite your batch script, relodge it. So it's a very different sort of situation. And obviously, even when you're running things internally, you might want to make use of cloud resources. For example, container repositories, Olama, Hugging Face, those sorts of things that are big repositories of various different models and weight sets. This means the two are basically chalk and cheese. They are very, very different workloads with very, very, very different sets of requirements. And in some ways, it's a little bit scary when you're standing there with a large batch machine looking at the differences that you have with AI workloads and how far they are from you. Especially when everyone starts throwing around the various different buzzwords that like everybody likes to use for monitoring things. Of course, AI is no exception, it has its own. So what a lot of organizations are obviously doing is MLOps, which is, you can see a link there to the MLOps organization. Basically, it's a methodology for designing and implementing the workflows that you will use to build your AI work, your AI solutions and your various different inference requirements. It covers most of the stages, or all the important stages of your workflow, and is been adopted by a large number of companies. Obviously, these companies have then made their platforms available, so some of those platforms, obviously with Amazon, you've got SageMaker, you've got Azure, of course, Google Vertex AI, Databricks, those are all sort of the cloud-based ones, and then obviously there's the internal ones. So there's MLflow, which is a stack you can run, there's Kubeflow, there's Metaflow, and there's a product called Ray as well. When you're looking at building your own sort of platform, you sort of need to sit down with a list of basic requirements that are going to be both from the organization and your users. And when you're looking at those requirements, you're going to come up with a list that looks something like this. Obviously, you're going to want authentication because you're going to have a lot of different users and a lot of different potentially groups who all need access, and they obviously want to know that nobody else is touching their stuff and you haven't got anybody who isn't supposed to be there on your very large, expensive system. You're probably going to want a local container registry, even just from the point of view of reducing your traffic ingress from the internet, because some of these models are ginormous and so are some of the various different packages that people would want to use. User management, of course, that goes hand in hand with authentication. Workflow design and observation, as we've seen in some of the other slides, having that visualization of how your workflow runs or doesn't run and where it falls down is something that a lot of people have come to both enjoy and rely on when they're doing AI ML workflows. A chart repository, and what I mean by that is something like Helm charts and that sort of thing, because obviously, again, a lot of this stuff sits on top of Kubernetes, and when you're dealing with Kubernetes, you've got to pick some sort of charting automation, with Helm being one of the big ones, but some sort of repository for all of the different workflows that you're going to use as the different parts of your solution. When it comes to the admin side, of course, billing and quotas, because as we all know, whenever you've got a big pool of researchers sharing something, everybody needs to have their share, their fair turn, and so being able to log all of that and view all of that from both the administrative point of view, but also from the user point of view, to know if have I burned through all my quota this month yet or not. And then the network access control, so making sure that you haven't got tenants jumping the fence and accidentally, interfering with somebody else's workload, because when it comes to these workloads, they are heavily networked. You've got multiple parts all communicating over the network, so you don't want two people sitting on the same address or port and causing each other problems. Storage interfaces are also something. When you've got Kubernetes, you probably already know, Kubernetes needs an interface to that storage, and so you need something that you can go, I've got all of this storage, and it can then handle that and then plug that in as required into the different parts of the workflows that people will build. And the last one, of course, not really last, it's fairly important, automated security scanning and alerting. Obviously, if people are pulling packages down, and we've seen it just recently, especially with, I forgot the name of the platform, that's good. A lot of the JavaScript libraries, one of the big major JavaScript repositories was just recently hit with a whole bunch of name squatting, for example. We've seen it in the past where Kubernetes clusters were used because, again, it was some library in some package that was a resource that got name squatted and it's come in. So having some sort of automated system checking for both known CVEs and other vulnerabilities in the containers that you're going to make available is obviously really, really big. And I can hear you all saying, that's a heck of a lot of things I need to build, and I've only got a limited number of people. What's an answer that's going to mean that I'm not going to need 100 new staff just to manage this one new piece of hardware? And as Werner touched on, RAFE. So RAFE is specifically the MLOps Kubeflow part of RAFE, because RAFE's got a lot of different parts. It gives you the whole sort of similar platform to some of the online ones, in that you've got an inventory of hardware. You then, after you've configured that in the RAFE, you can then carve that up and have multiple different profiles to suit multiple different workloads. You then have your users log into a web interface. They can say, I've got a workload that looks like X, I need this, and it will then set up in an environment for them that, as you can see, supports a number of the different common ML workload and ML AI workloads in a way that is very similar to a lot of the online platforms that people have already sort of used. As you can see, and you've seen this slide before, it has a number of large components that are already all pre-integrated into the platform. You've got things like the Jupyter notebooks, and you've got all the NVIDIA enterprise stuff. which allow you to do a number of really cool things as well. Workflow templates, GitOps pipelines, user management, basically everything that we touched on 2 slides ago. This already has it all built in for you to manage in a way that doesn't require a small army to keep going. Okay. Excuse me. RAFA does more than that, obviously. It's not just a web interface with some pretty hyperlinks. The idea is that when you build your RAFA infrastructure, it's going to have all of the different functions you need to present and manage the entire solution for your end users. So it covers backups, it covers blueprints, which is like very similar to the Helm charts and that sort of thing. It has a catalog, which allows you to then, of course, expand out with all of the different models and things that people are going to want, as well as the different containers and applications they want to run. Has a way to manage all of the costs, so you set up the billing rates that you need for everything, and it will actually keep track of that per user, or with different granularities, because you can also obviously have users or organizations configured within it, and it will actually keep track of the costs for all of those, making it very transparent. It allows GitOps style workflows, which are very, very popular in ML, which is all part of the MLOps. The idea is that you, well, I don't have to tell you guys what it is, but the idea is that by leveraging Git as the source of truth for all of your workflows, you then check the changes in, they then are reflected in your production workflows over time. It also obviously handles multi-clusters, so if you've got RAFA and you've got, let's say you've got an AMD cluster and you've got an NVIDIA cluster, you can have both of those so that you can, have different users on different ones, or to test one out against another, or to find the one that has the right price point for your particular users. Next big part of it is the IAM, so your integrated, so access control, user management, group control, organization structures. So like I said previously, it has multi-cluster support. It obviously also supports things like role-based access control, which everybody knows from Kubernetes. It allows you to integrate with external identity providers, which is huge because a lot of organizations will have an internal Active Directory, but then you also have external identity platforms, especially inside research, that branch across multiple organizations, so that way you can have a unified login with those other places that can then all have access to your platform. Obviously the audit and compliance, which goes into the security that I was talking about, you can see who did what, where and when, and there's multiple layers of that, so you can have it from administratively external, but you can also see if somebody in your team was changing things that you didn't really want them to be changing, and have that conversation later. And then obviously it has more layers of multi-tenancy that are built on top of that. So you can have, basically you can set things up so that your various internal organizations are able to administer their own projects and their own users to some degree. Obviously they have to be allowed to inside the wider organizational authentication access sort of infrastructure, but if they are allowed in, obviously then you can have project leaders carving up the project's time to the various different people inside the project, and they don't need any assistance or external support from the wider support teams that you would run. So the entire thing is built on zero trust principles. The idea there is obviously that once you're authenticated, the controllers then at every stage check to make sure that you are who you say you are, and you are accessing the things that the RBAC gives you permission to access, and that flows through all of the different parts of the infrastructure, not just the front page. As we were talking earlier, the built-in capabilities for chargeback and cost allocation purposes. That's an example of what it can do. It is able to present that at a user level, and then obviously administrative levels with different levels of breakdown, allowing you to effectively use your resources, and obviously also then keep an eye on where your project's at. And that's my job.
We have time for a couple of questions. Microphone's there. Yep. We have one.
Thank you for your talk. It was quite interesting. From the University of New South Wales, John says, wondering where, the solution that you propose, what sort of licensing terms and conditions are associated with RAFA in particular? Is it open source? Do we get visibility into that? Is it commercial?
Yeah. That's actually a really, really great question. So RAFA, its foundations are actually open source. There's a couple of projects that they directly, well, one of the major ones, which name escapes me, so come find me later and I'll show you the GitHub repository. But yes, it is completely founded in open source technology. Obviously, if you use the various open source components, you can get exceptionally close to RAFA. You're just missing the final polish, if you will, of tying it all together neatly, which is not uncommon with open source products. They get you 95% of the way. A lot of the time, it's the last 15 to 5% depending on product that you end up having to pay for. But as it is with a lot of projects, it's 95 is often the easy part. It's the last 5% of polishing that takes the longest, right?
Any other questions? We may have time for a quick one, final one before you go. We have one.
Yeah, great talk, thank you. So yeah, two questions. There was a dragonfly up on the slide.
Yes.
What exactly is that? The first one.
You've caught me at a disadvantage. I have my notes, but they're not here. So I'll get you an answer if you can find me. But I haven't got my notes on me.
Sounds good, thanks. And then, would you call RAFA kind of like a Kate's version of like OpenStack, like Kate's to virtualization? Is that the kind of
right? I see what you're asking. If you look at OpenStack as being the open source AWS, you could, in a large way, say it is similar, but it sort of has a bit more of a focus on the ML AI workflow direction. You can use it just to manage straight up Kubernetes if you wanted to, but you'd be leaving a lot of its capabilities on the floor. I have an extended version of this slide deck that also goes into some of the NVIDIA integrations a lot deeper. That's one of the really big things. In fact, without naming names, I was working with a customer recently who was building Kubernetes on top of a machine that had NVIDIA GPUs in it. And their biggest sticking point was making the two talk to each other. There are wonderful guides from NVIDIA on how to do it, but it is a lot of work, and if you've never done it before, it does present a number of challenges. So from my point of view, it's probably actually more like the Amazon, I mentioned it in the previous slide. Amazon has an ML ops sort of platform, which is AWS's version of the ML ops workflow lifestyle sort of situation. That's what this is sort of aiming for. The idea that you can just log in, I want to run 5 different models, these are the sizes, I'm going to need this much GPU, going to need to use this storage, these are my containers, here's my Helm chart, go, and just have it work and present you with